الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everybody. Before I get started, I'd like to thank a lot the Major General Rashid Thani Al-Matrushi for inviting me to this conference today and for giving me the opportunity to give you a little talk. And also, I would thank you all for the great hospitality and kindness. It's really my pleasure to be here today to give you a little speech on the world of nano, which is the small science and big deal. I will provide some examples on using nanotechnology and emphasize some key points and concepts in a simple way. So let's make a start. Before I go to the definition of nanotechnology, let me explain how small is nano. Well, like between this and this, your fingernail is growing 1 nanometer. Your hair is growing 1 nanometer. And for more explanation, I got some stuff to help you imagine how small is nanotechnology. When we look at agave, which is a kind of a plant with a narrow leaf, so let's imagine this is 1 meter leaf. When we cut this up into 1,000 equal pieces, okay, like one piece would consider as 1 millimeter, just like a snowflake. When we divide the snowflake into 1,000 pieces again, like one piece again, let's say this is the piece, equals to 1 micrometer. We still see it, but it's just like a powder or a pollen. When we divide this again into 1,000 equal pieces, we can get 1 nanometer. It's extremely small. And 1 nanometer is about 3 atoms long. And the atom is the smallest unit of the chemical element. What's the nanotechnology? I'm sure you've all heard of the meaning of nanotechnology, but I don't know if you've heard or not that nanotechnology is going to change everything. So nanotechnology is defined as a material, system, and device which can be controlled in size and shape, just like at the nanoscale. And this can be done by handling the atoms or removing them, just like by playing with the atoms. So we can fabricate different designs, productions, characterizations using nanotechnology. So that would can be used in different applications afterwards. Well, how can we get down to the nanoscale? We have 2 main approaches can be used to fabricate the nanostructures. The first one is called top-down approach. Top-down approach, yeah, which can reduces and break down here large pieces into very small parts here, just like at the nanoscale. This can be done by using mechanical and chemical and other forms of energy. The other approach is called bottom-up approach, okay? Or self-assembly. And this approach can be done by building up the atoms or molecule till we get to the nanostructure. In simple words, top-down approach means big system to smaller components. And the opposite is true with the other approach. Now you know the meaning of nanotechnology, the meaning of the nanoscale, and how can we get down to the nanoscale. But maybe you ask a question. Why should we care about this technology? What's interesting about it? And what's so great about it, like being so small? And why do we bother in trying to go so small? Well, there is what we call the nano advantage. And when we get down to small objects, usually properties are very different, which is important in science. And by doing this, and by going down, we can get new physics, new chemistry, new properties, and this only exists in the nanoscale world. With the unique properties, we can build here lots of materials with lots of properties. So we can get lighter, stronger, cheaper, smarter, durable materials which can be used in different fields. From computer, for example, we can get computers, the computers can become 1,000,000 times faster and 1,000,000 times smaller, which is really amazing. In medical, drug delivery or nanotechnology can be applicable in medical applications, like in cancer or heart disease. So it can help cure and detect lots of disease in more efficient manner than the conventional ones. Well, nanotechnology is a rapidly expanding field. And with the enhanced properties, we can get lots of materials, applications with lighter weight, with increased strength, and increased electrical conductivity and chemical reactivity, which is really great, and that's what we need. As one example, I chose the most important invention of the 20th century, which is transistor. Transistor, when we go back to the 1940s, transistor looked like this, with a size of your palm of hand, which is really big compared to the transistors invented in the 21st century. Yes, which is about 65 nanometers, very small. Both are similar principle, but instead of getting one transistor in a device, we can get billions of transistors in devices, and this would improve the would make interacting with your laptop, your cell phone, your tablet, and other devices easier with less power needed, and this is really great. This slide here shows some applications of using nanotechnology in lots of innovative application, like in energy, medicine, civil defense, security, and other fields. And I chose some examples to talk about today in the next slides. Nanotechnology is being used in medicine, in cancer, and other drug delivery, bone replacement, appetite control, and other applications of medicine. And as one example, I chose Doxil, which is on the market currently, and it's used as anti-cancer treatment for the ovarian cancer. Another example in imaging, quantum dot nanocrystals can be used to enhance the properties of the cancer screening. In cosmetics as well, we can use nanotechnology to improve the properties of like hair care and skincare products, makeup and sunscreens. As one example here, which is currently commercialized, nanotechnology can be used, especially like using titanium dioxide nanoparticles as UV filter. So it can block the bad light and just let the good light into the skin. Another exciting application of using nanotechnology in medicine. This is still under development, which is nano robotics. Well, imagining going to the doctor in future, and instead of taking medication, a pill, or a shot, you can swallow the doctor. I'm not joking, but not the real doctor. I mean like electronic robot doctor. So it can go into your bloodstream and detect the affected area and give it like the good medication needed. And that's very like, very amazing application. And lots of research has been done with that application. Okay, moving from medicine to energy, nanotechnology is being used in lots of applications to improve the efficiency of energy generation and develop new methods to generate energy, so it can help to solve the world's energy problem. There are lots and lots of applications of using nanotechnology in energy. I chose some of them. The first one is the windmill blades. And this application, used nano-coating to make the blades stronger and lighter and 8 times tougher than the conventional ones. And this would help produce more energy when compared to the conventional one, as the existing blades needs like more wind to turn because they're like heavy. And also less energy would be produced as they spin less. So nanotechnology would improve the property of windmill blades. Another example is using nanotechnology in solar cells. We have 2 main drawbacks with the conventional solar cell. The first one is the manufacturing cost is expensive when making the solar cells. Also, the efficiency of the existing solar cells achieves only 10% of producing energy. With using nanomaterials, we can enhance the efficiency from 10% to 40%, which is interesting, and we can make cheaper solar cell. And this is also interesting. I like this example, smart nanogrids. Smart grids is a solution for comprehensive management, remote monitoring, and maintenance of many micro and nanogrids for sustainable development of communities. Why is that? A unique feature of the smart nanogrid is the integration and comprehensive management of lots of resources like energy, water, agriculture, air, buildings, and so on into a single open source platform. And I believe this application can play a very important role in civil defense when it's connecting to the civil defense. So, in future, you can control fighting the fire in buildings from the center of civil defense, let's say just by clicking a button, which is really amazing. Also, nanotechnology has been used in developing lots of applications in IT or information technology. Well, there are two main areas that nanotechnology evolved in, including the use of nanomaterials to create smaller, thinner, faster, and more efficient memory of using nanomaterials in computer, and also to replace the current devices with the computers using advanced quantum computers. Nanotechnology also is being used in making applications in civil engineering and constructions, like in concrete, steel, wood, glass, and coating. As one example, nano coatings for glass, wood, and ceramic. Some example of using nanotechnology in like glass surfaces, glazed ceramic surfaces, window glass, and building glasses, and car glasses as well. And what do nanotechnology provide to the product? Well, it could provide a strong hydrophobicity. What does that mean? This is the surface of glass or ceramic, let's say. The nano particles could provide to the surface hydrophobicity or make it lacking affinity for water, just like this. So this is nanoparticles. It makes the surface fear of water. So it gives it here lots of properties like anti-contamination, self-cleaning, and fire protection as well, compared to the conventional glasses. Also, it can make it easy to clean performed on contamination and lime scale. Nano coatings also can provide lots of properties like self-cleaning, fire protection, which is very useful in civil defense, by using spray or just like put it directly to the surface of wood and glasses and so on. And there is a video I want to show you of, so please play the video, to show you like how nano coatings would prevent firing. The wood here is coated with nanoparticles, silica dioxide. It's called the silica dioxide. And you can see here, it's firing, but see, it protects the surface of wood. And you can just remove it easily. Really exciting. Also, nanotechnology can be used in concrete to make it stronger, durable, and also to make it light in weight. There are lots of nanomaterials used in concrete. Some of them are under development, others are already commercialized, like nanosilica, carbon nanotubes, and this is very important material in nanotechnology, and titanium dioxide. Why nanotechnology for concrete? Well, there are lots and lots of properties can nanotechnology provide to the concrete and other construction materials, such as bulk density, mechanical performance, and like make it more stable, durability, sustainability of concrete, as well as it can give it a property of fire protection. Well, now the question is, what's the world's strongest material? Is it a diamond, steel, or iron, or what? Have you heard of graphene? This is made of nanomaterial. It's a nanomaterial, a nanoscale material. Graphene just developed in 2004, and it's harder than diamond, and superconductive and stronger than steel. I'm not going to talk about graphene. I'll let the video talks about graphene now.
Graphene. Everybody's talking about it. When hearing some of its basic properties, you might have wondered if people were confusing it with some kind of substance only found in comic books. It's 1 atom thick, conducts electricity better than silver, conducts heat better than diamond, and it's stronger than steel. It would take the focused force of an elephant balancing on a pencil point to pierce through a piece of graphene as thick as plastic wrap. And yet, graphite is made of the same stuff. And yeah, that crumbly stuff used to make your pencil is a lot less impressive. So what's up? Graphene is made of carbon, and carbon has only 2 naturally occurring crystalline structures. Graphite, which is just stacks and stacks of graphene piled on top of each other, and diamond, which is a network of carbon atoms arranged into tetrahedrons, one after the other. For being composed of entirely the same element, those 2 things don't seem to have a lot in common. Diamond is clear, graphite is black. Diamond is a nearly perfect electrical insulator, while graphite is both a great conductor of heat and electricity. The differences between these substances all come down to the arrangement of their atoms. Carbon has 4 outer electrons. In diamond, all 4 of those electrons bond to carbon atoms around it, forming those tetrahedrons. This makes for an extremely rigid and strong crystal. It's an insulator because there are no leftover electrons to carry a current, and it's clear because light can't easily excite electrons that are tied up in such stable bonds, which is where they'd otherwise be absorbed. Graphite, on the other hand, is a crystalline form of carbon in which each atom is only bonded to 3 other carbon atoms. Those atoms form a 2-dimensional sheet of hexagons in which each atom has 1 unpaired electron left over. And those electrons will go flying across the matrix of atoms if you apply an electric current, allowing it to readily conduct electricity. They also gobble up any photons coming their way, which is why graphite is black. But while graphite is a great conductor, its natural form consists of
maybe that's
layers.
enough about graphene. Thank you very much. Yes, so graphene is very amazing material used in nanotechnology, and it could enhance lots of properties of applications in different fields, in medicine, energy, civil defense, constructions, and so on. Also, there are lots of applications of using nanotechnology in defense and the military, so in fabrics and materials, in security and weapons, vehicle and military personnel health. As one example, the clothing of the soldiers can be made of nanomaterials to make it more comfortable, high-tech, smarter, and to make it like the bullet proof, and so on. So lots of properties of using nanotechnology. Other applications of using nanotechnology in sport, personal care, cars, textile. I chose like using silver nanoparticles, antibacterial fibers in socks, and it provides a very amazing property to the socks. So it takes the smell of the socks, even if you just wear it for a week, by using the silver nanoparticle. Also, nanotechnology can be used to enhance cars and make it stronger, lighter, with enhancing the engine of the car and the fuel consumption as well. At the end, the future that we were watching in science fiction movies will be real in the near future just by using nanotechnology. Nanotechnology covers lots of applications and will cover more in future. Lots of inventions can come true by using nanotechnology soon. We just need to give it a try. Thank you for listening, and that's all for me.